Hello YouTube. Today we're going to be making a Sieve of Eratosthenes app. We're going to use the Sieve of Eratosthenes algorithm to go through an array of positive integers and remove all the non-prime elements. So let's go ahead and get started. Okay, so what is the Sieve of Eratosthenes algorithm? Let me just go ahead and explain this really quickly. So the first thing it's going to do is eliminate 1, and we're going to start counting on the first prime number, which is 2. And what are we going to do? We're going to check every multiple of 2 that is not 2 and remove it. So let's go ahead and do that. So what are the multiples of 2? We have 4, 6, 8, 10, and 12. Okay, so now we've gone through the whole array and we've removed all the multiples of 2 that are not 2. Now we can go ahead and move to this element and we're going to do the same exact thing. So what are the multiples of 3? 6, already gone. 9, let's take that out. 12, already gone. And we're just going to be repeating this process, and eventually the result will be an array of only prime numbers. Okay, so I've just gone and created a basic HTML document here with the script tag in the body. And the first thing we're going to create is our arrays. So we're going to have 2 arrays. One's going to be for the positive integers. And the other one is going to be for our prime numbers. Okay, let's go ahead and define array size. You can make this really any number you want. I'm going to use 500. If you go into the more massive numbers, you start to get super slow load times. And if you go too big, you'll get a stack overflow. So just make sure it's not too humongous of a number. Okay, so we have our arrays of a defined array size. Now we want to generate positive integers into number array. Now, if you have experience with for loops, you could do this with one of those, but I'm going to do this recursively. So this is going to look familiar to you if you know for loops. We're going to set a counter I to 0. And this is going to be the counter for our recursive function. Okay, now if you were in a for loop, it'd be for let I equals 0, I is less than array size I++. So we're going to do something super similar here. So we're going to create the function. It's going to be called addNumber. And just like in a for loop where you will say I is less than array size, we're going to do the same thing here, except we're going to do it in a while loop. So while I is less than array size, what do we want to do? We want to assign positive integers. So I'm going to say number array I, which is the current incrementation we're on, and I'm going to set that to I plus 1. And that's because I want our numbers to start counting at 1. So then we're going to increment I++, just like in a for loop. And then we're going to recall addNumber. Okay, so let me just explain this real quick. We're starting at the 0th element, going up to array size, non-inclusive. And for every element in the array, the current counter we're on, we're going to assign that value to the current counter plus 1. Then we're going to increment I and recall the function. So this should work. Let me just make sure. Let's call this function out here. And then let's console log our number array. Okay, so as you can see, we have an array of 500 elements starting at 1 and should be ending with 500. Yes. So that's working correctly. Now, the next thing we want to do is our actual Sieve of Eratosthenes algorithm. Now, this is where I'm going to start using this prime array. I don't want to affect the values in number array, so I'm going to copy the values from number array into prime array. So we'll say prime array is equal to array.from number array, and this will put all the values inside number array into prime array. Okay, so let's go ahead and write our Sieve of Eratosthenes function. So before we actually write the function, if we go back to our whiteboard here, you'll see the first thing we're doing is we're eliminating 1, and we're starting our check on 2. So let's create a new variable called current check and set it to 2. Okay, so now we can write this function. We'll call this function, and what it's doing is removing non-primes. Okay, so if you watched my last tutorial on JavaScript sorting, you'll recognize the syntax. It's basically a bubble sort. So we'll say bubble sort like algorithm. And we're going to do the same thing we did with the sort, is we're going to create a nested for loop. If you want a more detailed explanation on how bubble sort actually works and how these nested loops are actually doing what they're doing, I'd recommend going and watching the JavaScript sorting tutorial. Or really, any YouTube tutorial on bubble sort will work. Okay, so now let's create our inner loop. So in very basic terms, for every time we increment through an element of the array here, we're incrementing through the whole array here. So on element 0, we'll be going through the whole array. On element 1, we'll be going through the whole array. Element 2 will be going through the whole array, so on and so forth. Okay, so what do we want to do? Like I said here, the first thing we want to do is eliminate 1. We want to just get this out of the way. So let's just create a if statement. So if prime array, the current incrementation we're on is 1, we want to delete that value. Okay. We can say remove 1. Okay. And now this next if statement is going to check and remove multiples. Okay. So I'm going to introduce this cool operator here called modulus. And basically what this is doing, so let's see. So if you divide 2 by 2, what is the remainder? The remainder is 0. So 2 modulus 2 is 0. Same with 4 modulus 2 is 0 because there's no remainder. 6 modulus 2 is 0, and so on and so forth. So you probably see the idea here. We can check if something is a multiple of something else by using this modulus operator. So let's do that. We're going to say if prime array of n, remember modulus, current check, is 0. And then what else did I say here? I said remove all multiples of 2 that are not 2. So we're going to add another condition here. We're going to say and prime array of n is not equal to our current check, which is 2 right now. Okay? So if it's a multiple of current check and it's not current check, what do we want to do? We want to delete that value. And then out here, we want to increment current check. Because like I said here, once we've gone through the whole array and removed all the multiples that are not this, we can go to the next number. So we're just going to be incrementing current check. Okay, so that is basically it. So let me call this down here. Okay. And now I just want to print this data on the web page to make sure it's working instead of in the console. So I'm just going to do a document.write, and I'll say, I'll use backticks, array of positive integers. Close each one. Okay, and then I'm going to use a for loop to print out all the values in number array. So for j is 0, j is less than array size, j plus plus. Okay, and then we're going to document.write. We're going to use backticks again so we can use HTML. We're going to put in the variable number array of j. Okay, so now we should have our whole array of positive integers printed. So I just want to do this. Okay, so 1 to 500 all printed, perfect. Now we want to print the prime array. Okay, just copy this, add a couple line breaks. then we're going to do the same thing. So we can do this again. Array of prime integers. And we're going to say for var L is 0. L is less than array size. L is plus. Okay. Now this delete, this doesn't actually change the size of the array. All it does is it deletes the value in the element. So we want to set a condition here. We want to say if the prime array value of the current incrementation we're on is not null, so if there's actually a value in there, then we want to print it. Okay. If I can type prime array L and put a space. Okay, so this should work. Let's see. All right, so let's look. We have 2, 3, 5, 7, 11, 13, 17, 19. Let me just search for prime numbers just to verify. Okay, so if we look here, let's see. 2, 3, 5, 7, 11, 13, 17, 19. 2, 3, 5, 7, 11, 13, 17, 19. So it looks like it works. So that's it for this tutorial. I hope you learned something new. I hope you learned a little bit about recursion. I hope you learned a little bit about algorithmic thinking. And I hope that you learned a little about prime numbers maybe. So thanks for watching. If you enjoyed, please subscribe and comment and like. I would really appreciate it. Have a great day and goodbye.